Yes, hello members, you are most welcome. As usual, I am back, Saddam Hussein, your mathematics teacher. I hope you people are doing very well. And all this time you have been following, subscribing, viewing. Thank you very much for the great work you are doing. And I told you that this is the channel where practical lessons are posted time and again. And we have them here time and again. You will always get them. Otherwise, I really appreciate you so much. I don't know which other word I can use to make you feel that I'm so happy of what you are doing, but allow me use the word thank you, thank you, thank you very much. Now, today we want to still look at those practical questions. I told you that we are looking at how knowledge can be applied in our daily lives. Remember, the trend we are following in examinations now, in everything that we are doing, is how best can someone apply the knowledge. That knowledge, how best can it be applied to be used? And in our daily lives, you can easily make a child understand that, okay, this is something that they have picked from our daily lives and it is in class, so that mathematics doesn't look so much abstract. Yes, it looks so practical, and the learner picks more interest even to learn. You know, when something is practical, when something is within your jurisdiction, within where you stay, you really feel that, oh, this is something we do. Now, for example, let us look at this question, and then we see if you are really to teach the way it's supposed to be taught, how best can a learner get interested to learn it? Thank you. So that is under circumference, and in particular, we are looking at revolution. We are looking at revolution. Last time we looked at it under the leap years, and we were able to comprehend and see how best can be done. Now, as we are going on, we shall know what these things mean. How many revolutions? How many revolutions can a bicycle wheel? How many revolutions can a bicycle wheel of diameter? The bicycle wheel of diameter 35 centimeters make to cover a distance of 8.8 kilometers. How many revolutions can a bicycle wheel of diameter 35 centimeters make to cover a distance of 8.8 kilometers? Now, what do we mean here? If this is the distance, assuming that we have the distance of 8.8 kilometers scaled down to be represented here like that. So this is a distance of 8.8 kilometers. Now you have a bicycle. You know, this is what we call the bicycle wheel. This one here, the one I'm drawing here, it has those spokes. Practically, we know it has those spokes there. I'm drawing only one, but of course it must have two wheels there, but we are specifying on one. Now, if that's the bicycle wheel, the diameter, the distance from here across the center up to this is what we call the diameter, which is 35 centimeters. This distance from this point, this arc here, through the center to another arc, it's what we call the diameter. From the circumference this way through the center, the circumference is the diameter. I've used very many ways of explaining it. Now, this bicycle wheel has a diameter of 35 centimeters. What they are asking is, how many times, if this is the point where it is beginning from, how many times will this same point land on the ground to cover a distance of 8.8 kilometers? What they mean here is to revolve, to make a complete turn. Making one complete turn, that one becomes one, the second one, two, the third one, like that, until it covers 8.8 kilometers. If this is the point that you have marked. Now, when you roll this wheel until when this point comes back down, that's what we are meaning. This point comes back down, this point that you marked here, that's already one turn. When it comes back again, that's the second turn. When it comes back again, that's the third turn. So those are revolutions. One revolution is equivalent to that one turn that it makes when you move this wheel from this point and turns until when this one comes back to point to the ground where it was. That one makes one revolution. So how many times will this bicycle tire or bicycle wheel keep revolving to cover a distance of 8.8 kilometers? You have always seen our colleagues riding bicycles. We cannot naturally count it that let me sit and follow this bicycle, how it is going to make this wheel. So how will you keep moving with that bicycle until when you keep counting? It is very hard. So mathematically, we can only ascertain the distance that that person has to cover. For example, if you are moving from a certain center to a given village, we can say, for example, if it is 8.8 kilometers as it is being indicated, fine. Then from there, you only need to know the diameter or the radius of the bicycle wheel. After knowing it, we can easily know how many times this wheel will revolve, will rotate. To make one complete revolution, as I told you, from the point where it began, like if this is the point we have marked on it, on the bicycle wheel, by the way, until when this point comes back down here, you can practically try it using just an ordinary wheel at home there. Doing it just along a distance. You can make a distance of some maybe 100 meters. Then you tie a thread around a given point. So you roll this wheel or tire until when that thread, each time the thread touches the ground, you count. That's 1. Roll again. Each time it touches, that is 2. When it touches, that is 3. You keep counting. So that time, each movement is what you call a revolution. So how many times will it make that movement or the revolution such that it covers a distance of 8.8 kilometers? This one, I am begging that when we are teaching it to our learners as teachers, make them come out practically. The distance may not be 8.8 kilometers because it's too far. You can make it a short one. 100 meters is fine, even 50 meters, as long as you can be able to measure the diameter or the circumference or the radius of that wheel. Then after that, you tie some thread or you put a mark so that you make the children observe as you are rolling that tire. Let them keep observing. Remember, speed doesn't matter. The revolutions, as long as it, you can't just touch this to untouch it. Even if you move slowly, as long as we touch. Even if you move very fast, as long as we touch, because it keeps revolving. That's what we're talking about. The revolution on the speed measure. The revolution can be very fast, but that it doesn't change the number of revolutions. I hope we're clear there. Speed doesn't change the number of revolutions, but can make it faster. You can revolve faster, but doesn't change the number of revolutions. This one, what I want to tell you clearly. Now, one revolution, when this wheel makes one revolution, which is 1 turn, is equivalent to the circumference. Is equivalent to the circumference of that wheel. Meaning that we are supposed to know the circumference. So, because remember, when it makes 1 turn, it must make throughout, it must revolve from this point until it comes back. So you must know the circular distance around that wheel. Remember, the wheel is circular. So you must know the distance around that circular wheel. Are we together? That is the circumference. The distance round a given figure, which is circular. Distance around a circular figure is what we call the circumference. So we need to know the distance, at least around that circular figure. Then from there, we shall get the next step. So given the diameter, remember, circumference is given by pi d when we have the diameter. Circumference is 22 out of 7 times diameter, which is 35 centimeters. Circumference is 22 out of 7 times 35 centimeters by 7, 1 by 7, 5. So when you multiply here, you will have circumference giving us 22 times 5 centimeters. So circumference is 110 centimeters. Now, after getting circumference, we already have the distance. But what we need to do here, when we have the distance already, we have the circumference already, we shall divide the distance by the circumference to get the number of times. Remember, we already know that 1 time, or the distance around the whole wheel of that bicycle, is equivalent to 110 centimeters. So how many 110s? Actually, that's the language I can use here. How many 110s will be there to cover a distance of 8.8 kilometers? How many 110 centimeters will be there to cover a distance of 8.8 kilometers. That is something very simple, by the way. How many 110s? So we are now getting number of times this wheel will rotate, or the 110 will be put in account, will be counted there until when you make 8.8 kilometers. Now, we cannot get that without matching the units. This is centimeters. We are either supposed to convert this one or we convert some, but I always see we should convert the bigger unit into smaller units. So, converting 8.8 kilometers to centimeters, and 1 kilometer is equals to 100,000 centimeters. Yes, King Henry's daughter Mary drank cold milk. So you can see this is what I'm meaning here. King Henry's daughter Mary drank cold. This is centimeters, then this is milk. So from here is 100,000. So what about 88 out of 10 kilometers will be equivalent to 88 kilometers out of 10 divided by 1 kilometer, by the way. So when we divide, we get the reciprocal, which will still be 1 out of 1 kilometer times 100,000 centimeters, by the way. So these kilometers will cancel, then this one will cancel with the other one. So this one is 88 times that, 1, 2, 3, 4. These are 4 zeros here. This is centimeters. So 880,000 centimeters. That's now the distance. Now to get the revolution, we divide distance by the circumference to get the revolution. That is how best we can do it, and things will be fine. Now, revolution equals to distance, which is 88 centimeters, divided by circumference, which is 110 centimeters. So revolution equals to 88, 4 zeros, don't forget them, out of 110 centimeters. So this centimeters will cancel, this one will cancel, by 11 1, by 11 8. So the number of times is going to be 8,000 times, or tons. So calculate the revolution that can be made. The revolution here will be 8,000. That means this 110 will appear 8,000 times. This bicycle wheel is going to rotate 8,000 times. Remember, when we have got the distance, we express that distance that we have, which is 8.8 kilometers to centimeters. Why we match it? We want the units to be the same. Remember, you cannot divide 8.8 kilometers by 110 centimeters. Those units will be different. You have to first of all match them. Most preferable, I told that you convert the bigger unit into smaller unit. We know that kilometers are bigger than centimeters. So you convert kilometers to centimeters to make it more easier to be divisible. So after getting this answer, we now say distance divided by circumference. Remember the number of times. Why we are dividing distance by circumference? So that we are getting the distance that the wheel is supposed to cover divided by the circumference. The number of times that 110 will keep rotating will be counted. Remember, one revolution the same as 1 turn, which is circumference, which is the circumference. So distance around the figure, that is 1. Now when you divide the distance by circumference, you will be getting the number of times this wheel has to rotate. Number of times the wheel has to rotate in order to cover that distance. I think that is clear, and more explanation is still there. In my comment section, you get them there. And secondly, you will answer that exercise. That's going to appear right there. You will answer and see whether you have understood it well. But revolution, I told you, it is practical. Do it practically with your learners and everything will be fine. Other, thank you for attending. May the Almighty God bless you so much.